Here we go. Been a while. Here we are. We have test number 2 on Wednesday, which means, of course, we'll go through the practice test today. I want to review the video that you watched on combinations just a little bit, but we've got some practice problems from the practice test as well. So we'll see. Okay. Okay. Yeah, like I said, they used to have kind of, why is it so mean? I can do this. Let's do this. It looks even meaner. Anyways, you can do it. Test 2 on Wednesday. If you've done the practice test, I will say it's longer than the actual test. I should have called it practice for the test. Okay? The test, you'll want to keep your pace up, but it's not going to be that long. Okay? And so before we start the practice, just a tiny bit of review, because I do want to spend most of it on practice. But any questions before I jump in here? So in the video, you learn about combinations, right? And it was a nice short video, I thought. As promised, you worked so hard finishing the material so that the video would be nice and short. So combinations, we've been dealing with permutations, right? And so permutations are where order matters, okay? And so I'll add that here maybe. Permutations are when order matters. So just as some examples, right? First place, second place, third place, right? It matters who you put in first place. It matters who you put in second place, right? Because the person who won first place can't win second place, right? And so that would be a permutation. And so first place, second place, etc. Right? So you kind of have to talk yourself into does order matter or not, right? And so one of the ways you can solve with slots, which I tend to prefer, right? Like this, 1, 2, 3, maybe first place, second place, third place, right? That kind of thing, or a tree diagram. And I caught one as I was reading it. I didn't catch it, sorry. It says use a tree diagram, but I'll tackle that one. You don't have to, you can use the slots. Okay. So you can use slots or a tree diagram, I should say, to solve permutations. Okay. Versus combinations is when the order is not important, right? And so how do you determine if order is not important? Well, if you're just grabbing a group of 3 people, right, then there's no reason to say, oh, you're going in this slot, and then you're going in this slot, and you're going in this slot. I just need to grab a group of 3 people from, let's say, 10 people, right? And so that's how you would determine that order is not important. And so, for example, select a group of 3 people from 10, something like that. That's really tricky, right? I find that reading a question and talking myself into, does order matter? Does order not matter? Right? I find that that's really difficult, and that comes with practice, right? And so, but what you'll find is that the more of those types of questions that you read, and then you start to think, oh, I've seen a question like this one before, and I solved it with permutations, or I solved it with combinations, and then you can kind of go from there, right? And so it becomes kind of pattern recognition in a way. The number of combinations of n objects taken are at a time, right? And so here in this scenario, this would be, R would be 3, and n would be 10, right? And choose R, right? From a group of 10 people, choose 3, right? You can calculate it using the factorial, and on the test, there will be a question saying, hey, calculate this NCR question using just the formula, right? Where you have to show me that you remember how to cancel stuff. Okay, good. And so, right? But it's very similar to the permutation formula, NPR, right? And so you have n factorial divided by n minus r factorial times r factorial. So it's just got 2 factorials in the denominator instead of the 1. Okay, good. And that's on your formula sheet, which I appended to the practice test. I'll do this. I'll practice 4 test 2 to clarify. Otherwise, it's too scary. I put together some core concepts, really just kind of a summary of what we did, right, in each of the chapters. And so, doesn't it all sound so fancy? I know, lucky you guys. I snuck on the formula sheets. Of course, I'll bring fresh copies of the formula sheet for the test, right? And if you don't have a copy, I've got some spares up here. But for sets and counting, we have only these 2 formulas, right? The rest are all kind of just understanding what is a permutation, what is a combination, right? And set theory. Okay. Any questions before we get started? Here we go. So I am concerned about having enough time. So these kind of quicker questions, I am going to move through them quite quickly so that we have time to talk about those longer. There's some longer ones, right? And so they're going to be really important. And then whatever we don't finish, I'll record in a second video, because I keep forgetting there's a class in here afterwards, so I can't stay here, but and then I'll post the second video. So you'll have everything in case we run out of time, not to worry. I will have the test in order, in the order that topics appeared, which might be helpful for the permutation versus combination situation, right? And so, because that means that the combinations will be last. Right? You just need to kind of talk yourself into, is it a combination? Okay. Whereas on the final exam, they won't be in order anymore, right? Then you've outgrown that. But for this test, they will be in order. Which means we start with simple interest. If an amount of $2,000 is borrowed at a simple interest rate, so notice how it says simple interest, right? Telling me which area of the formula sheet I'm working in, right? It means that I'm working here with these guys. I'll just do a little shorty version. Okay. So that's going to be important, picking out kind of which section of the formula sheet are you working in. So we borrowed $2,000 at an interest rate of 10% for 3 years. How much is the interest? Now, what are we trying to find? We want to find I. Capital I is the amount of interest, right? There's a lot of ways that you could solve this, but I think the easiest way would be I equals PRT, right? Which means that I need a P, which I have, right? Here's P, and I need an R, which is 0.10, and T is 3 years. Oops. T equals 3. You want to make sure that your rate and your time frames match, right? Here, the rate is just given as 10%, right? Not yearly or monthly or anything like that. So we can go ahead and say that I equals PRT. I want to see the blank formula that you're about to use, right? And then I want to see it filled in. And then the steps in between that and the answer are optional. And so I want to see 2,000 times 0.10 times 3. Now, if you did middle steps here, that's cool. But I think in this case, you can just go straight for 600. Oh, nice. Nice and breezy. Any questions about that one? Okay. Hopefully I calculated. 2,000 times 0.1 times 3. Yeah. Okay. Question 2. John borrows $2,400 for 3 years at 9% simple interest. I'm going to highlight that again because that's now going to be your job to keep track of, hey, is this simple interest or is it compound interest? Right? And so he borrows $2,400 for 3 years at 9% simple interest. How much will he owe at the end of 3 years? So how much will he owe? We want to find A, right? The accumulated amount. Now, from my formula sheet, because it's simple interest, I'm going to use A equals P times 1 plus R times T. You could, if you wanted to, although it's kind of a weird move, you could say, I'm going to calculate I, and then I'm going to use the fact that I equals A minus P, and you would find the same answer, right? So there's a couple of different ways that you could do it. As long as you show your work, I'm happy. I'll follow through and make sure it makes sense. And if it makes sense, you are good to go. P times 1 plus R times T. But like I said, since I want to find A, I'll go for the A formula. So if you borrow 2,400, that's your P for 3 years, and your R is 0.09. Right, make sure that you convert your rate to a decimal. But besides that, A equals 2,400 times 1 plus 0.09 times 3. Should I show? Let's see here. I'm just gonna go for it. Get $3,048. Even, which is nice. Nice. Any questions about that one? No. How about question 3? A city library has ordered a new computer system costing $158,000. The system will be delivered in 6 months and the full amount will be due 30 days after delivery. How much should be deposited today into an account paying 7.5% compounded monthly to have $158,000 in 7 months, right? So 6 months and then you have 3 months or 30 days to pay it, so 7 months. Now, what I want you to pay attention to is the compounded monthly. Yeah? So we want to have some lump sum that we want to deposit, and we want to make sure it grows to 158,000 in 7 months. So let's see here. I want to, how much should be deposited today, which means we want to find P if R is 0.075, compounded monthly, which means my N is 12. And I did say, as we were introducing these compounding frequencies, right, in the test, I'll pick, straightforward ones like monthly, right? Quarterly, N would be 4, right? Semi-annually, N would be 2. But that's not what the test is about. So if you're reading a question, you're like, oh man, I totally forgot what this N should be, just ask, okay? So that's not what I'm testing you on. It's okay. You can just ask. It's fine. And I'll tell you. How about that? Yeah, that wasn't meant to be like a cruel, you can just ask and then I won't tell you. No, I'll tell you. Now, if it's compounding monthly, then we want to make sure that our, I can't remember, now I can't remember how, I usually convert my T into years. Is that what we've been doing? Yeah. Nice. Which means 7/12. Right. And, oh yeah, and then the 158,000 has to be our A, right, our accumulated amount, right, because that's how much we need. If you wanted to draw this out, it would look like this, right? After 7 months, so today, we're going to deposit some P and it's going to grow to some A equal to 158,000. You don't have to draw that, right? Totally optional, but just if you wanted to visualize it. I don't usually draw those simple ones. It's those bigger ones that I draw. Forgot where my formula sheet was. So for compound interest, right, we've got a lot of different options. Now I want to solve for A, or sorry, I want to solve for P, but I have an A, which means I can use this one. All of these formulas, except for the last one in the compound interest, is just the first one rearranged, right? Solving for P, solving for T, solving for R, right? All the possible things that I could get you to do. Since we have it, I'll just use, so used to the formula sheet being in a different spot. So I want to find P, and I'll write out my equation here. P is A times 1, or A divided by 1 plus R over N to the N times T. A is 158,000 divided by 1 plus, 0.075 divided by 12, right, monthly. 12 times 7 divided by 12, which will get you back to that 7 months. Okay. I will do a middle jump here. And just to show that you can skip this step. This is optional work, right? You don't need to show the light blue stuff. As long as you're showing all the dark blue stuff, I'm happy. But what I'm going to do is I'm going to simplify the denominator just so that you can check your work, right? And so 0.075 divided by 12 plus 1 is 1.00625 to the power of 7. Now from here, I'm just going to go for it. 151 to 57.1222. Presumably repeating. And then I want to see it rounded to 2 decimal places, 257 and 12 pennies. So I want to see the full number, right? So that I can make sure that you did carry all your values through and then rounded to 2 decimal places for money. I'm going to move this next one down here. Oops. Where did this 1 come from? 151. Oh, I see. Oh. I'll do this. Must show work written in dark blue. And down here. So you're allowed to skip that light blue one. Nice. So you'd have to invest $151,257.12, and in 7 months it will have grown to $158,000, so you can pay off your bills. Questions about that one? Okay. Let's see here. Oh, it's up top, Emily. Find the effective interest rate for an account paying 7.2% compounded quarterly. Now, the effective interest rate, do you remember what the effective interest rate? It's the annually compounded rate that would give you the same accumulated amount as 7.2% compounded quarterly. Now, I will point out that for effective interest rates, they'll always be pretty similar to the rate that's given. So if you are finding something like 9%, something went wrong. Okay, I'm expecting it to be around 7.2. Right, 7.1, 7.3, those are okay. Right, maybe even 7.5, but anything beyond that would be probably wrong. So you've got the formula for the effective interest rate. I should be jumping to a different file. Down here, right, the effective interest rate is down here. Oh man. So the effective interest rate is 1 plus r over n to the power of n minus 1, where n is the compounding frequency that you're coming from, right? And then the effective rate is the annually compounded rate. So we want to find our effective. And we have our R is 0.072, and compounding quarterly, I do expect you to know that one, is 4 times per year. And let me just, had them all set up, but I didn't really map it out. So the effective interest rate is 1 plus r over n to the power of n, then minus 1. You don't want to forget this minus 1. Otherwise, you'll have rates of 100 and some odd percent, 107%. And that's a lot. And it wouldn't be right. 1 plus 0.072 divided by 4 to the power of 4 minus 1. As long as you take it nice and slow, 0.072 divided by 4 and then plus 1, right? And then to the power of 4 and then minus 1. So again, just to show all the steps, I'll do it in light blue. And so 0.072 divided by 4. So I get 1 plus 0.018 to the power of 4 minus 1. Just bump these down. 1.018 to the power of 4 minus 1. Puts me at 1.073967433 minus 1. Oops. 0.073967432998. The light's flickering in here. So the effective interest rate, you can just leave it as the decimal, right? Or if you prefer, or 7.397%. I don't want to go to 7.4, even though you could, because it doesn't say, right? But for a little bit more interest, 7.397 is pretty close to 7.2. Right? It's kind of in that wheelhouse that I'm expecting it to be, right? And so I'm happy with that.
But you have taken 7.4.
Yeah, that's fine. As long as you show all of them first, that's fine. This is the one I'm looking for, really. Yeah, since I didn't specify. I mean, technically, there is a rule that you just match whatever was given, so then 7.4 would be right. So I can't blame you. I just like to see all the interesting numbers. Any other questions about that one? Okay. At the end of each month, Rita deposits $300 in an account that pays 5%. What will the final amount be in 4 years? Now, we have to pay attention here because at the end of each month, she deposits this regular amount, right? Which is what makes it an annuity. Okay? And so here, at the end of each month, it's an annuity with M equal to 300. Okay? And so here are our annuities, right? Whenever you're making regular payments, right? Weekly payments, monthly payments, annual payments, right? Then you have an annuity. And we wanted to know, oh, I forgot what we wanted to know actually. But we'll be working with these formulas quite a bit, so I'm just going to bring them down. What will the final amount be in 4 years? Which means that we want to find A. We have T, which is 4. We already decided that M is 300. And how frequently are we doing it? We're doing it each month. So N is 12 times per year. And an account that pays 5%. So R is 0.05. So if I want to find A, right, then that's going to be the future value. So I want to use this formula here. Notice that this formula doesn't have an A in it. It does work off of A, right? This right-hand side, they're the same. So technically this is A, right? But we're solving for P in this case. So for our question, we want to use this formula here for A. Oh. But the hard part is figuring out that it's an annuity, right? And that you have to solve for A, right? So those are the hard parts. I know. A is M times 1 plus R over N to the N times T minus 1 divided by R over N. Plug in the numbers. M we said was 300 times 1 plus 0.05 divided by 12 to the power of 12 times 4 minus 1 divided by 0.05, oops, divided by 12. Optional work is simplifying each of these steps, right? I do find that using the store function and using just the previous answer button on your calculator, it'll be more efficient to just skip to the answer, right? But that's going to take a little bit of practice. Okay? And in the solutions, I want you to see what the steps would be, right? So where do we start? We start with 0.05 divided by 12, right? Inside the, is that in here? Can't tell. Hearing things. Is it just me? Is there like, there's a murmur? Oh, it's real people. I'm used to people just not being on mute, usually. 0.05 divided by 12 is not anything nice. So I'm going to use the store function. Let's see here. Oops. 300 times 1 plus 0.004166. Repeating. Oops. That's not in the numerator anymore. Spooky. 12 times 4 is 48. And then minus 1 divided by 0.004166, repeating. It's nighttime now, I guess. I'll get sleepy. 0.05 divided by 12 plus 1. I'm just gonna go for it here. To the power of 48. 1.220895355 minus 1. That's 300. 66.2686061. Oops. Just gonna bump these guys. Wait. Bump these guys down. Finally, I think we're ready to divide by, what was it, 0.05? 15904.46556. As many as your calculator shows, but then in money, 15,904 and 47 pennies, rounding properly. And I'll clarify again, this light blue is optional work. You don't have to show it. You can always check to make sure, right? What would you expect it to be if there was no interest involved, right? $300 a month. So 300 times 12 is 3,600 for 4 years times 4. 14,400. I'm expecting my answer to be higher than that, but not a lot higher than that, right? Because I'm earning interest as well, right? And so that's a nice way to check to make sure that your answers make sense, right? Is just kind of, okay, ignore the interest, and then it should be more than that because that's how interest works. Any questions about that one? No. Okay. Question 6. A firm needs to replace most of its machinery in 5 years at a cost of $500,000. The company wishes to create a sinking fund to have this money available in 5 years. Now, a sinking fund is just kind of that special case where you make payments and you accumulate to a desired amount. Right? How much should the quarterly deposits be if the fund earns 8%? Now, let's see here. We're given that T must be 5. And I want A to be 500,000. How much should the quarterly deposits be, which means that N is 4? How much should the deposits be? That means you want to find M. Use same color scheme here. If the fund earns 8%, so if R is 0.08. If you want to find, yeah, sorry.
Why is the 500,000?
Because if you need the 500,000 5 years from now, then that's the future value. Whereas if you were depositing 500,000 and then adding some amount, right, then that would make it P, but usually it's A if we're doing a sinking fund. Which means we're going to have an annuity, right? So that's a good place to start. And we have an A, and I want to solve for M, which means I'm going to use the same formula as before, just solving for M instead of A. This light is driving me nuts. A is M times 1 plus R over N to the N times T minus 1 divided by R over N. Oops, I want A. I'm going to force A to be 500,000. And the M is what I'm solving for. R is 0.08 divided by 4 to the power of 4 times 5, then minus 1 divided by 0.08 divided by 4. Now I'm not going to show all the steps because they're very similar to the one that we just did, and it's very time consuming, as you know. What's nice is 0.08 divided by 4 is 0.02, so that's nice and clean. I should have written out the steps for this one instead of the other one because it was so long. That's okay. Plus 1 to the power of 20 minus 1. I'll check in here with some optional stuff. 0.485947396 divided by 0.02. With multiplication and division, it doesn't matter. You could multiply the 0.02 over and then divide by 0.04859, blah, blah, blah. Or you can do the division over here and then divide it over here. You'll find the same answer. So then M, oh, maybe I should show some more work here. Divided by 0.02. $24.2973698. So M is 500,000. Oh, this is actually also optional work. Make sure you get the right number of zeros. I get 20578.35906. So does that match?
I got exactly $10,000 difference because I did it wrong.
Oh. Sometimes I catch a face and I'm like, I did it wrong. I can tell, but okay. Oh.
$10,000.
Yeah, that's weird.
I got 30,578.35906. And then rounded it up.
Crazy. Magic. 36, round it properly. Questions about that one? So again, you can check your work, right? Make sure it's reasonable. What would you do? Well, this amount 4 times per year. For how long? Well, let's see here. Times 4 times per year is $82,313-ish per year that they would deposit. And for 5 years, so times 5, puts me at $411,567. Now, that's okay, right? It's kind of close to 500,000 because that's how interest works, right? But as long as you're in the ballpark, right? If you were getting like $1 million or something, then something went wrong. But just to check in. Of course, you expect that if you are kind of depositing money before you need it, right? That means that you need to deposit less money to you, right? Than you would at the very end, right? So you don't need 500,000. In fact, you need $411,567 in cash and deposit it quarterly, blah, blah, blah. But that's the time value of money. How about this one? Is it better to receive $400 each month for 6 years or a lump sum of $25,000 today if the interest rate is 7%? And then explain. I ask you to explain because is it better? Well, that's up to you to determine which one's better. I like the one that is more money, but if you don't, then you can tell me that that's better. And that's your explanation. And so we still have to do the math, but for the record, I prefer the one that is more money. So what are we going to do? We want to compare $400 each month for 6 years, right? Versus a lump sum of $25,000. Just you get $25,000. And so what we're doing is first, let's see here. What color can I do? We want to compare something like this. So here we are today. And for 1 month, 2 months, all the way to 6 years. 6 years has 72 months. Right? And we get $400 each month. Oh, 4,000, that'd be nice. Those $400 are worth something today, right? They're not worth 400 times 72. They're worth less than that, right? But that's the amount that we want to compare to 25,000. Right? And so we want to compare this P, compare P to 25,000. Right? And then presumably pick the larger of the two. But you get to explain, so you could tell me whatever you want. Because I have these regular payments, right? That's my M. And it's monthly, which means my N is 12. My T is 6. It's kind of inconsistent on writing out. I'm lazy sometimes. and R is 0.07. So I want to find P for these regular payments, right? Which means I have to use this next formula, our biggest formula. For the principal amount. Just as a note, if you do like to visualize it like this, if you find that you're pulling the arrow backwards, right, that will always be a P, right? Versus if you're pulling your arrow forwards, right, how much would you have after 6 years? That's going to be an A. And so you always have P, then A, right? And so I find that that helps when you're visualizing. But I want to compare the values today, and so that makes it a P. So here we go. P times 1 plus R over N to the N times T must be M times 1 plus R over N to the N times T minus 1 divided by R over N. Notice that we're leaving this 25,000 out of the equation, right? It doesn't have a place here because I want to compare P to 25,000. So, plugging in our numbers, here we go. And gonna need another page here. P times, because I'm solving for P, 1 plus R, which was 0.07, divided by N, which is 12, to the power of 12 times 6 years, is M, which is 400. Need a bigger screen. 1 plus 0.07 divided by 12. Yep. 12 times 6 minus 1 divided by 0.07 divided by 12. Taking it nice and slow, but what's nice is once you've solved this here, 1 plus 0.07 divided by 12 to the power of 12 times 6, that's the same number as here. So I encourage you to store it in your calculator and save yourself a bunch of work. You don't have to, but I would definitely try to do that because it's a nice shortcut. Now, 0.07 divided by 12, real bummer, not anything nice. So I'm just going to go for it to the power of 12 times 6. P times 1.520105504. To show what I mean, I'm going to store this in A. And then I'm going to do 400 times whatever is stored in A minus 1 divided by 0.07 divided by 12. So from here, minus 1 times 400 divided by 0.07 divided by 12. $3,566.37743. Which means that P is 35,664, blah, 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 divided by whatever is stored in A. Divided by recall A. I get a P of 23461.77771. 1, 2, 3, 4. Sure. Whatever. It's gonna round to 78 pennies anyways. 461.78. Is that what you guys got? Any questions? So which one do you prefer? Do you want $23,461.78, or do you want 25,000? I'm gonna go for 25. I would much prefer that. I would prefer 25,000 today instead of the payments worth 23,461.78 today. Personal preference, but I'm feeling good about it. Nice. So comparing different payments, right? Different options. Which one's better? Which one do you like? This one's such a downer, but it is kind of the most common scenario where you would have to figure out what the value of a payment plan is kind of midstream. So 14 months after Dan bought his new car, he lost his job. His car was repossessed by his lender after he had made only 14 monthly payments of $376 each. If the loan was financed over a 4-year period at an interest rate of 10.3%, how much did the car cost the lender? In other words, how much did Dan still owe on the car? So, whenever you want to figure out how much is still owing, right? What you want to do is you want to take the payments that haven't been paid, right? And pull them back to the point where they have been paid to. I think the easiest way to do it is to visualize it first, or for me to show you what I mean here. You don't have to, but it might be nice. So let's say I like to start today. You can think about 14 months ago if you want, or something like that. But let's start today, and then so he buys his new car and he's making monthly payments, 1 month, 2 months, and he makes payments all the way up to 14 months. Then he loses his job. Sad face. He's still committed to paying this car for how long? 4 years. 4 years is 48 months, which means he's still committed to paying these number of payments, right? And so what I want to do is map out, okay, let's see here. 15 months all the way up to, let's say, 47 months. And he had committed to paying $376 every single month for 4 years. But here This is where he lost his job. Now what's happened is these payments that he's committed to, presumably he paid this last one. Let's assume that's the case. Otherwise, we don't know the formula. And so you can figure it out. But let's assume that he made that last payment and then he stopped making payments. Okay, just kind of how it reads anyways. So what you want to do, these payments, I need to know, well, what's the value here? And if I'm pulling my arrow backwards, that's a P, right? Now that's the value. How much did he still owe on the car? That's this P. Yeah? And so where P, right? This P is where P is the amount still owing. So one thing that you could do is just imagine this is all gone, it's paid off, that's squared up, right? And so you can just pretend that didn't happen, but that changes your T, right? You want to make sure that your T now is from the 14 months to the 48 months, right? And so here, we have to adjust T, adjust T to be 48 months minus 14 months divided by 12. You could do 4 years minus 14 months, or however you want to get there is fine. But 48 minus 14 months is 34 months. Divide by 12, right, in years. Oh, I'll get rid of this M here. 34/12 of a year. For 34 payments, right? N times T is the number of payments, right? But you don't need to keep track of that, but it might help. 34 years. 34 over 12 years. Okay. So what are we given? We have our M. We have our R is 0.073. T is not 4 years anymore, right? We've made that adjustment. It's 34 divided by 12, right? And we're making monthly payments, which means that our N is 12. And is that all we need? I think so. Which means we want to find, how much did Dan still owe on the car? We want to find P. If you want to find P, then that's the same formula here, but just make sure that you've adjusted your T. Yeah. The 12, oh, because I'm converting T into years. Because this would be 34 months. Yeah. Yeah. So if you want to convert the number of months into years, you have to divide by 12. But I will clarify here that this distance is 34 months. Nice. Okay. P times 1 plus r over n to the n times t is m times 1 plus r over n to the n times t minus 1 divided by r over n. Boy, I'm remembering that right, but I'm feeling pretty good. Hopefully. I want to find p. P times 1 plus r, which is 0.07. How did I get 0.073? That is so weird. 0.103. Having a mental glitch, I guess. Weird. Good thing I caught it. 0.103 divided by 12. 12 times 34 divided by 12. So that n times t here is always going to be the number of payments, right? And so it should be 34, right? 12 times 34 divided by 12 is 34. So it checks out. Is M, which was 376 times 1 plus 0.10, oops, 103 divided by 12. 12 times 34 divided by 12 minus 1 divided by 0.103 divided by 12. I'm gonna go for it here. 0.103 divided by 12 plus 1 to the power of 34 once I cancel. It's me at p times 1.3372133542. Oops. Which I'll store in A. Minus 1 times 376 divided by 0.103 divided by 12. Now, if you're doing all of this in the numerator divided by 0.103 divided by 12, you want to make sure that you use brackets around the 0.103 divided by 12. Otherwise, it might jump out, which is effectively multiplying by 12, which you don't want to do. I get 14,771.91751. So P $11,046.79024 in monies, $11,046.79. That's how much he still owes on the car. Yeah.
What he's already done, like what he's already paid, because he paid 376 for 14 months. So 376 times 14 is 52. We know exactly.
Because we only pulled the arrow to the 14-month mark, you don't want to do that, because then you can solve it like that, but it would be harder. Because if you're taking off these payments, right, then what you would have to do is pull this arrow all the way back, which we know how to do, right? You can solve for P today, but then you would have to also solve for P of these 14 payments and then subtract them. So it's like double the work. especially solving for P is really hard, really big. So, but when you pull it just to here, because he's made these payments, right, we're not penalizing him for that. We're saying, okay, you paid those off, great, but you still owe these payments, and that's all that P is taking into account.
Cause I did it where I took P for the 4 years.
Mm-hmm.
Out the 14 months, which I'm now realizing is wrong because I would have had to do the 4 years, you know, and make it a year or 2 years.
So you, yeah.
I mean, I
And
don't
I'm-
want it. However, I'm just wondering.
Yeah, like why wouldn't it work? Can you compare the values here?
I wonder if it's a difference between like years of time. Cause I did it like the 376 times 14 months.
Right.
And then I did when I told you 4 years. I don't know if there
Oh. Could be. Have a look. But if you're trying to find how much is still owing, then do this. It's going to be the cleanest way, right? Kind of using that as your stopping point and figuring out your P at that point. It's going to be the least number of calculations at least, which is always nice. Woof. This one's a biggie. Yikes. And I gotta check the time here. All right. We're doing all right. Until this one. Mrs. Garcia is planning to retire in 20 years. She starts to save for retirement by depositing $2,000 each quarter into a retirement investment account that earns 6% interest compounded quarterly. Find the accumulated value of her retirement savings at the end of 20 years. Then there's a follow-up. All right, we can do that, but then there's a follow-up. Then assume Mrs. Garcia has now reached retirement and would like to make equal monthly withdrawals for the next 15 years to completely deplete the account. So she's saving for 20 years. And then she says, for the next 15 years, I'm going to make regular withdrawals until it's all gone. And we want to find the withdrawal payment. Assume the account now pays 5.4% compounded monthly. This is one of those two-phase problems, right? Making deposits and then making withdrawals. And so I want to sketch it out. So let's say she starts today and she's going to retire in 20 years. It's very distracting with the light. So 20 years from then, she's going to retire. She's happy. But then for 15 years after that, she's going to make withdrawals. She's depositing $2,000 each quarter, which means every 3 months. So 1 quarter, 2 quarters for 20 years has 80 quarters. And she's depositing $2,000 each quarter until retires. Now that's going to be worth something when she retires. In fact, it's going to be worth A, right? Pulling that arrow forwards makes it an A. right? An accumulated amount. Jotting down some information about this region, which I'll call phase one, because we've been calling them kind of two-phase problems. Oh, let's move this down just a line or two. Because then what's the trick? Then she wants to make equal monthly withdrawals for the next 15 years, which means that kind of at this point, this turnaround point where she retires, now she starts the clock on these 15 years of monthly withdrawals. All right, so 1 month, and for 15 years, there's 180 months. Oops, 180 months. 1 month, 2 months, 79. And she wants to withdraw some unknown amount, M. But all she has to pull from is this A, right? But these M's, when I pull them back, have to be worth some P, right? But that's that trick that we learned where we said, okay, well, first phase one, I'm going to solve for A, right? Then for phase two, this A turns into my P, and I want to solve for M, right? So we've got this kind of phase one, phase two situation. Another thing to keep track of is if the interest rates are the same or if they're different, they're going to be different. And so what I want to do is just jot down the information for each phase, right? T is 20, T is 15. Here, M is 2,000. N is quarterly, which means N is 4, right? Quarterly payments. Whereas here, N is monthly, so N is 12. And it earns 6% interest in phase one, and it earns 0.054 in phase two. So we have to solve for A in phase one, and then use that as our P in phase two to solve for M. Here we go. Solve for A in phase one. A is M times 1 plus R over N to the N times T minus 1 divided by R over N. Let's do this thing. A is 2,000 times 1 plus 0.06 divided by 4 to the power of 4 times 20 minus 1 divided by 0.06 divided by 4. 0.06 divided by 4 is just 0.015, but I'm just going to go for it. Plus 1 to the power of 4 times 20. Make sure you use brackets. Minus 1 times 2,000 divided by 0.06 divided by 4. Make sure you use brackets around that again. And I get, not writing down any of that optional work in the interest of time here, $305,421.7049, which as money is 305,421.70. So now I have this amount, right? And that's the amount that I'm going to be pulling these M's out of, right? And so now we use that A that we found as our P, right, to solve for M in phase 2. So now use P equal to 305,421.70, right? Which is from there to solve for M in phase 2. Now I have a P, which means I have to use that biggest formula. I do want to check in though. Is this the A that people found? Phew. Because I don't want to go to the next step with the wrong number. That is great news. P time, and also good job. Yeah, good job to you. Good job to me. And to the T minus 1 divided by R over N. There we go. 305,421.70. 1 plus. Now make sure you change your R and your N, right? And your T, of course. But I think that one's kind of obvious, but make sure you pay attention to your R and N. 0.054 divided by 12. Uh-oh, I said it was obvious, and now I have to make sure. 12 times 15. Oops. Bump this over here. M is what I'm solving for. 1 plus 0.054 divided by 12 to the power of 12 times 15 minus 1. 0.054 divided by 12. Okay, here we go. 0.054 divided by 12 is nice, but small. I'm just going to go for it. Plus 1 to the power of 12 times 15. Make sure that's all in the power. Store that. Times 305,421.7. I get 685,313.4972. Which I'm gonna store in A, I guess. 0.054 divided by 12 plus 1 to the power of 12 times 15 minus 1 divided by 0.054 divided by 12, use brackets. M times 276.4060294. Recall A divided by that guy. Find that my M is $2,479.372,461, which means that she would be getting $2,479.37 per month for 15 years. Not bad, I think. Because what she started with, I mean, she was saving for 20 years, but she was only only to a large amount, but she was depositing $2,000 quarterly, right? Which is every 3 months. And then for 20 years. And then now what we're finding is that she would be able to withdraw 2,400. So that's almost 2,500 every month, which is frequently, right? More frequent than quarterly for 15 years. That's pretty good. Any questions about that one? All right. Yeah. Oh, more? More. Good. And then, of course, I will make you do an amortization table, but right. And so let's go through this one. This one's kind of sneaky, right? Because there's a down payment involved. So the Gomez family bought a house for $775,000. They paid 20% down and amortized the rest at 11. We're going to have multiple parts here. We're going to find their monthly payment, and then we're going to complete the table for the first 3 payments, and then how much interest is paid on the loan over the entire 30 years. Okay, let's see here. Most important part is that when you make a down payment, the reason you make a down payment is so that you don't have to borrow that amount. It's already paid off, and you don't have to borrow it, which means you don't have to pay interest on it, which is why it's nice to have a big down payment, because then you're borrowing less and you're paying less in interest. Right? So let's see here. I'll do part A down here. Find their monthly payment. So they bought a house for $775,000, but then they paid 20% down, which means we're going to start by, we need to find the down payment is going to be 775,000 times 20% or 0.2. Right, 20% of 775,000. And maybe I'll do that down here so it's easier to see it. So how much would you need? Oops, I didn't do anything. Times 0.2. That's going to be $155,000. 20% is a large percentage, right? And so you kind of check, multiply that by 5, okay, should get back to 775,000. Good. This is cash, right? They're paying it down. They don't have to borrow it. And so the amount borrowed then is going to be 775,000 minus 155,000. $620,000. Huh? Those guys are making me nervous. Okay, got a little bit of time. So this is going to be our P. P for the loan. That's how much they're paying off. So when we're finding their monthly payment, right, really what we want to do is we want to use the 620,000 as our P, right? And we're given some other information here. We have the rate, which is quite high, 0.112. T is 30. And we have a monthly payment. Oops, so N is 12. All right. I should make this part is not optional. How you find the amount for the down payment kind of is optional. Right? If you're able to do it in your head, or what else could you do? You could do 775 times 1 minus 0.2, right? Drawing on our discounts, but that's not something I expect you to do, but could. So then, here we go. P times 1 plus R over N to the N times T is M times 1 plus R over N to the N times T minus 1 divided by R over N. Using this P and the rate and the N and the T, I want to solve for M. So I have 620,000 times 1 plus, what was that rate? It was super high. 0.112 divided by a monthly payment, so 12. 12 times 30. M times 1 plus 0.112 divided by 12. 12 times 30 minus 1 divided by 0.112 divided by 12. Okay, 0.112 divided by 12, I'm going to assume is, oops. If I do minus, then it's even worse, divided by 12. It's nothing nice, so I'm just going to go for it. Plus 1 to the power of 12 times 30 times, oh, I'm going to store that, times 620,000. Make sure you get the right number of zeros. 1757336.69. M times, let's see here. I guess this is optional. M times, oops. Recall A minus 1 divided by 0.112 divided by 12. I get 29.718,899. Finally, M. And let's do dark now. I get a payment of 5,998.291065. Or in monies, $5,998.29. Luckily, interest rates are not 11.2%. I should remember, we just had to renew one of our mortgages and it was 4.01 or something like that. 4%. Pretty standard right now. If you're curious what the interest rates are. Okay. So, huge monthly payments. Doesn't matter. Here we go. So that's part A. That's also going to be the same entry for all these payment amounts, right? So that's kind of boring, but easy, right? And so let's see here. I'm just going to copy this down, paste it. Because we have 5998.29 and they're the same, which I'll cheat and use the ditto mark. I don't know if that's the actual name of it though, but it means the same as above. How do you calculate the interest? The interest is just for that 1 month, right? And so the interest, I should do a little I equals PRT, where P is going to be the previous balance, right? And the rate, P, the rate was huge, 0.112, and for monthly payments, the T is 1/12 of a year, right? 1/12. Which means we have to have our starting balance, right? $620,000 as your P, right? That's all you're paying off. Yes, you bought the home, but you've already paid cash, right? That's done. So you've got your $620,000 as your initial balance. And so we didn't do this in class, but I've made you a 0 line so that you can have your first balance there. Yeah. Which ones?
Like the interest debt.
No. I'll give you the table just like this. And then you have to know to do this. But yeah. And then you fill in the table. No. That's okay. No, you don't. As long as you filled in the table, that's fine. Yeah. So the interest here is going to be the previous balance, right? 620,000 even. 1, 2, 3 times 0.112 and then times 1/12 if you want to be proper. No surprise, just disappointing. You're going to be paying a lot in interest, right? Especially in the beginning, right? As you pay more and more off, right, then you pay less in interest. Okay? But I'm getting a huge number, 5786.67, rounded properly. And hopefully that's what you found too. Okay? Which means that only a small amount of this huge payment is going towards our debt payment, right? And so notice that I've rounded to 2 decimal places, right? Because it's all money. And so 5998.29 minus 5786.67 means that only $211.62 is going towards your debt. But what does that mean? It means that the balance here is going to be 620,000 minus $211.62. And so 62 or 620,000 minus that guy. Now I have 619 788.38. I always want to see just two decimal places for money. Let me check the, okay. Kind of as I anticipated. I'll do the sets and counting, which are actually a lot quicker than the financial math section in a separate video for you guys. But now this is my new P, right? And so this is what I'm paying interest on. Now I use that here times 0.112 divided by 12 effectively. And so times 0.112 divided by 12. Now, as a way of checking your work, this answer should be slightly less than the first one, right? Which it is. It's, yeah, let's say $2 less, right? Because you're paying interest on a little bit less money, right? So now taking from the payment amount, 5998.29 minus 5784.69. Now I'm paying off $213.60, chipping away at the 619,788.38. 619,788.38 minus that guy. I get 619,574.78. Again, slightly less than before. The only one that should be increasing is the debt payment, right? As you pay less in interest, more of your payment is going towards your debt. So now for the final line here, 619,000 blah, 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 times 0.112 divided by 12. 5782.70, rounding properly. 5998.29 minus, oops, I did it wrong. 5998.29. Now's not the time to be making mistakes. Slightly higher, 215.59. Take that away from the previous balance, 619,574.78 minus that guy. 619,359.19. Oh, this is a 9. There was a last piece here. How much interest is paid on the loan over the entire 30 years? How are you going to figure that out? Well, you're making 30 years worth of payments at $5,998.29, right? And so monthly payments, 30 times 12. So here, 30 years is 30 times 12 equals 360 payments of 5998.29, which means the total paid is 5998.29 times 360. I'm going to go across just to keep it on the same page. Times 5998.29 to 159,384.40. Oof. That's how much you paid. How much did you borrow? 620,000. All right. And so interest paid is going to be the total paid minus borrowed, which is 2,159,384.40 minus $620,000. This one's gonna sting you guys. I gotta find a line somewhere, but I'll add it later here. 153,938.4. See here. 1, 2, 3. $1.5 million in interest. That's a terrible interest rate. Don't do that. Okay, so we're out of time. I can tell there's people at the door. But I'll sit down, record these solutions, and post them. Okay? If you have any questions, let me know. Otherwise, I'll see you on Wednesday for the test.